individual algorithmic traders with professional tools. Then in 2022, Jason and I started Quant Science. Our goal to give you the algorithmic trading strategies that hedge funds actually use and execution with Python's open source quant software. Our results? Overnight, students were leveraging algorithms to make trading decisions in our trading community, and they were winning in our live trading competitions. So why did I share this story with you? Well, it's because algorithmic trading is the past, the present, and the future for growing your investments. Because now any individual trader can grow their trading account if they have access to hedge fund quality trading algorithms and professional grade tools. So you have a choice. You can become part of the 95% of people who don't use algorithms or pro tools, or you can learn how to wield them. My portfolio just crossed $7 million, and some days I make over $100,000 on autopilot. You can do it too. All it takes is the right algorithmic trading strategies and hedge fund grade tools. And we're going to show you how today. So who is ready to step into the future of algorithmic trading with hedge fund grade professional tools? Drop a 1 in chat if that excites you. Whew. All right, we're seeing some ones. Good, good, good. Hopefully you like my little story there at the beginning too.
Love that story.
All
That's right, a
right.
party.
Well, guys, welcome to how to become a pro algorithmic trader with Python. Again, I'm your host, Matt Dancho. I'm joined with me by Jason Strimple. Wave hi, Jason.
Hello, guys.
And
Yes, we
uh,
are
we
live,
and we are also joined by our spirit animal, the Python snake right here, because obviously we love Python.
obviously.
Okay, so we're going to talk about how you can get hedge fund quality trading algorithms and professional tools today. That's our focus here. We're going to help you. Why are we doing that? Well, it's so you can compete at an unfair game. Now, in case we've never met before, my name is Matt Dancho. Nice to meet you. And I am not a traditional quant. I graduated from Penn State with a degree in mechanical engineering. This is my actual degree. And then I made a career pivot into data science. And through taking courses at home, I became really good at Python and machine learning. So good that these Fortune 500 companies began hiring me. You may recognize this one, S&P Global, big Fortune 500 firm. If you've ever heard of the S&P 500 index, they run that and they do a ton of other stuff. And then also Apple and many other small companies too. I co-founded Quant Science with Jason Strimple. Jason is the best quant instructor I know. And together we bridge the gap between machine learning and trading. Now, I've traded a lot before I met Jason. I began in 2007 by listening to this guy, and he recommended this stock. I bought it, I bought more, and then they went bankrupt. And at the ripe old age of 24, I lost $30,000 of my own money. That was a difficult moment for me because $30,000 was my entire life savings at that point. I'd been living on these things for 2 years to save up that $30,000. But one of the things I'm most proud of is coming back from that. It's going from losing $30,000 in 2008 to today having a growing portfolio and financial freedom. In January of 2024, my portfolio had crossed 4 million. By March, it was up to 4.7 million, and it continued to grow and grow and grow and grow. So what helped me get here? Well, I've invested in a lot of courses. I bought this one in 2021. Spoiler, it taught technical trading and it didn't work. It wasn't until I found Jason that I could piece this stuff together. Now, allow me to introduce Jason. Jason has over 20 years of quant experience at companies including he was the derivatives trader at Trade Group, trading risk manager at JP Morgan Chase, global head of derivatives market risk development at BP Trading, and head of engineering, data science, and analytics at Rio Tinto. The best part about Jason, though, he doesn't just talk stocks and options. He actually trades these, and this is his, I call this the cockpit. It is basically like a space shuttle cockpit. This is his computer screen. A little bit jealous, not going to lie. But he actually trades stocks and options from his home. And most importantly, he gets results. You can see, and just imagine, guys, being up 53% in less than a year and doubling the S&P 500's performance. Jason did it. Some of his portfolio metrics, his cumulative 12-month portfolio performance of 50%. Amazing. And that's why we teamed up. It's to help you win at an unfair game. And today we are excited to announce three new things. So three new announcements today. I'm pumped for this, Jason. Are you pumped?
I'm very pumped, man. I can't wait to hear it.
Okay. All right. Let's do it. I'm going to dive
Let's
right
get it.
into it. Here's announcement number one. Without further ado, Jason and I are officially launching our own fully automated algorithmic hedge fund powered by Python. I'm super pumped. This has been a dream of ours for a long, long time, and we've now built all the infrastructure that we need to do it. So we're ripping it off. We're getting ready. We're doing it today. The second announcement, Jason and I are launching three new Python software packages and that are powering our hedge fund. You will see them demoed live shortly. And the third announcement, Jason and I are launching a new system to teach you the exact algorithmic trading strategies and the exact professional tools that are powering our hedge fund, and you will be invited to join the journey along with us. And we have a full demo to share how to start and scale your algorithmic trading from A to Z with our pro algorithmic trading software. All right, who's ready to see what we built? Drop a yes or no in chat.
Woo.
And yes, it
Yes.
is fully automated. Jason is going to show you the
I'll
full
show you how it works.
automation. He's got everything. It's amazing. It's insane. All right, let's do it, guys. Let's do it. I'm pumped. Jason's pumped. We're doing it. So 18 months ago, true story. 18 months ago, Jason and I started this as a side project. We said, all right, what do we want to do next with our careers? Well, why don't we build a hedge fund? And we decided to build a hedge fund from scratch with Python, which is the language that we knew. And as we dove into it, and as we built our hedge fund, we realized that the Python algorithmic trading ecosystem was fragmented and incomplete. Okay. So we noticed some issues. We discovered three needs. The first need is financial data processing and storage was missing. Okay. Zip files and random CSVs weren't being tracked. Fundamental data was missing. Pipelines for data ingestion and cleaning were absent. Professional grade data warehousing solutions and data lakes, while they exist in Python, they weren't available for financial analysis. They weren't designed for what we're trying to do. And because of this, moving data was slow, painful, and riddled with errors. Okay. So this screenshot here is meant to symbolize what my computer looked like. All right. So my computer, imagine having zip files and folders and downloads and all these CSVs everywhere. And it looks like this. It looks like a cluttered mess. I hate that. Right. I became super tired after trying to, create this hedge fund and just organize the data of dealing with messy CSVs and slow data analysis. And what happened was it was killing our profits. All right, need number two. The next thing that we realized and we recognized was that we need a quant research experiment tracking system that was missing. Okay. So what we were doing was we were using Jupyter files, and the problem is they're untrackable. Imagine having strategy version 1, strategy version 2, final, IPython notebook, research backup 2025-02, IPython notebook. It just gets messy. Okay. So the problem was is that there's no quant data science experimentation pipeline. So without it, that makes tracking all of our experiment parameters, our performance, and the strategy comparisons that we needed to make virtually impossible. Okay. So this screenshot, this is like literally what my, IPython notebooks looked like. All right. Untitled 1, Untitled 2, Untitled 3. Anybody else in that same camp? Come on,
Oh yeah.
admit it. You're there with me. And then it's really tough though to track your strategies when my best strategy is labeled use this one.ipython notebook, right? So there's got to be a better way. All right, we'll get to that in a minute. Third need, execution management, automation, and monitoring was missing. All right. So there's no automated execution pipeline that is set up for trading. There's automation software in Python, but none of it's already pre-configured for what we had to do. There's no trade monitoring. So we need to be able to watch our trades. And if something's going wrong, we need to know about that. We also need to report our KPIs or key performance indicators. There's no audit trail. So trades that are sent from a strategy, what they have to do is we need them to be traced back to a specific backtest or a set of parameters so we know what created those and got that performance. Also, there's no multi-strategy management. And that made it impossible to run more than one strategy at any given time and separate out the performance. Our process, because of this, suffered. Our zipline bundles would be outdated or broken. We'd read in the wrong data. We'd inadvertently use incorrect trading strategy because use this one was no longer the right strategy to be used. Our trading strategies contain data errors. Our strategy would overfit because we'd backtest them incorrectly, and our trade executions would fail. Every one of these problems along the pipeline would cost us money. Now, imagine for a second the ideal workflow. I'd start by automatically downloading all of the trading data into a high performance data lake. Then what I would do is I would create and backtest dozens of my trading strategies from a unified research lab that is connected to the data lake. And then once I found a strategy that worked, I'd use a robust execution engine to not only submit the trades, but to monitor them to make sure that they were profitable and in alignment with my backtest results. Well, today I'm excited to introduce the Quant Science vision. One platform, three pillars that includes a high performance data lake designed for financial data, a high performance quant research lab, and a robust execution engine and trade monitoring system, all three under one roof. It starts with our first software, QS Connect. What QS Connect is, it's the financial data backbone. It includes automated data ingestion, file caching, high-performance database storage, and automated zipline bundling. Next is QS Research. QS Research is your quant research lab for feature engineering pipelines, factor analysis, with built-in machine learning workflows and a hedge fund quality backtesting system. Then finally, Omega. Omega is the execution engine, complete with 32 live connections to interactive brokers, now upgraded with trade monitoring, reporting, and automation. Who's ready for a demo? Give me a thumbs up if you want to see what we have built in action today. Enough talk. Let's see some code, right? Am I right? You guys came here for a Python demo, right? All right, well, let's do
It's
it.
like they want to see some demos, Matt. Got a lot of
Yeah.
thumbs up.
Okay. All right. I'm going to stop my share and I'm going to hand the screen over to Jason. And what he's going to do is scare the living crap out of me because he's going to do a live demo of our actual hedge fund and he's going to give away all the secrets that we've compiled over 18 months.
Matt loves when I do live demos. Do you guys like live demos? Just give me a one in the chat if
The,
you
the
want
other
to
thing that scares
see.
me with live demos is things are, things can break, right? Yeah.
We've had a pretty good run. I don't think we've broken yet, but hey, today's a new day.
Yep.
All right. So what are we looking at here, guys? Let me orientate ourselves. So we talked about three libraries, right? We talked about QS Connect. We talked about we talked about Omega. That's the big one. And we talked about QS Research. So these three libraries, plus a fourth one that I'm going to surprise you all with called QS Automate, are the four libraries that take you from start to finish. They will go out and download both historical price data, daily, intraday, if you want intraday. We had a question in the chat about intraday. It will also get historical financial data. So this is balance sheet data. This is income statement. This is ratios. And I'll explain why that is super important in a couple minutes. But let me first get into a little bit of the code here. So how many of you, just put a one in the chat, if you guys have heard of Prefect, Prefect, Prefect. Just put a one in the chat. This is a popular orchestration tool that allows you to run a series of steps in a row. So we've co-opted Prefect to run the fully automated system. So I'm going to show you how Prefect works, at least within our framework here, and then within each of these functions, how our proprietary tools work. So QS Connect, QS Automate, etc. So what you're looking at here is a simple function, right? So I don't know, 30 lines of code, 40 lines of code or so. And what we're doing is we are going out to download historical price data. And we are doing that with our QS Connect library. So from QS Connect import client, we create the client. We go out and get the full list of stocks. I think there's like 30,000 US, actually international equities in this data set. We do some filtering here. So we are getting, stocks as opposed to ETFs, for example, and only those on the NASDAQ and NYSE. And we're doing a quick filter of greater than $5. Okay. We will re-include ETFs as the benchmarks, and QS Connect makes it super easy to go out and download all of this data, right? So one function call, one method call, start end, caches the data as Parquet files on your local computer, and it automatically rate limits the requests out to the API just to make sure that we're not breaking anything. QS Connect is doing all of this under the hood. So I'll show you the code. It's like 3,500 lines of code that goes out, pulls all this data in, stashes it as Parquet files, and everything is written in polars. So how many of you know polars? Just put a one in the chat if you've heard of polars before. Hyperfast data frame manipulation data. So this goes back 30 plus years. We're going back, I think, to 1990-ish. So more than enough historical data for anything that we would use. And then after the data is downloaded and cached, it will actually store it in a high performance data lake, which we use DuckDB. So DuckDB is a in-process relational database, which plays very nicely with polars. Under the hood, everything is using DuckDB. So very, very fast. So the first thing we do is we go out and download price data. The second thing we do is go out and get historical bulk financial data. So I'm going to let you in on a little secret here, why this is super important and where this matters. Every single person on Earth can go out to Yahoo Finance and download a bunch of price data. Every single person on Earth does do that. And then they go out and put their technical analysis on it, and they will try to derive trade signals, and they will lose money. Why this matters is that your high performance data lake here is actually creating a quantamental data lake, which is quant finance, right? It's quantitative trading, but you're getting the financial statement data along with the price data. So in addition to just looking at price data, you can assess companies on things like value. So like we call it the Warren Buffett factor, right? You can look at low PE stocks, high PE stocks, and we'll see what actual data comes into play in a couple minutes. This is a huge edge for non-professional traders to get all of these retail folks above where most retail folks are trading. Okay. So that's why this is so important. And QS Connect makes it super easy to go out and get all this bulk financial data, to sync it up. So we're detecting if there are cache files, if there are missing files, we go out and get those. We detect duplicates, so we're not duplicating data. And then we're loading all the data into the database. So instead of having to go out to Edgar or going out to here, going out there, pulling in spreadsheets, calling APIs, making sure all the dates line up, format, standardizing, it's doing it all for you in 3 function calls. Super simple to do. And all of this is wrapped up in our task. And I'll show you the UI in a second. And I'm actually going to run this. Let me just run this. I was running it earlier. So I'm going to start the task, okay? And I'll show you what this looks like in the interface. So what you're going to see here is I'm going out and starting to download all of the data, and I am fetching. So you can see fetching income statement data, and you're seeing pulling down all of this historical data that I don't yet have. So I'm refreshing my cache. Okay. Now, if I go over to my web browser, I have this prefix server dashboard running, and this is our task monitoring system. This allows us to make sure that everything is running correctly. And you'll see here, if I go to my dashboard, if I go to my runs, I've got this QS momentum thing running. I've actually got 2 instances of this running, and you get all of this data that goes into, these are all the inputs. So all this traceability, all this tracking, and I'll show you where this all comes from shortly. So we get to track how all this works. And you can see this one's been running for an hour and a half because it takes a while to get all this data, okay? So that's the first 2 tasks. So first thing we do is go out get price data. Second thing we go out and do is fundamental data. Now, the third thing we need to do is prepare our backtesting. And we do all this automatically. So the way that this system works is we want to do what I call as parallel trading. And what that means is kind of 2 things. For this particular strategy, this is a momentum strategy. We are running the backtest engine. We are taking the orders that the backtest says we should be placing, and then we are automatically placing those orders into the market. So we're using the backtest engine as our analytical framework. And what that allows us to do is track the performance of the backtest at the same time as the performance of our actual strategy. And I will show you how that works as well. But this is exactly how the professionals do it. Here's another pro tip, another secret. You want to calibrate your backtest to your live trading, because if your backtests and your live trading are not the same, then one of those 2 is broken. Your backtest is not adequately representing what you're doing in the market. You will lose. Okay, this is a big thing, a big no-no in non-professional in professional trading, and most non-professionals don't do it. This automated system will allow you to do that, and I'll make it super easy for you. In 3 or 4 lines of code, we are using QS Connect, the data that we have built and just cached, and we are ingesting the zipline bundle from those tables. If you've never used Zipline Reloaded before, it's the best event-driven backtesting framework that exists in Python, but it is tricky to get the data ingested into the framework, okay? This used to take about an hour and a half, and we've taught, I think Matt and I have taught 500 students. I've taught another 1,500 students how to use this technology. And this is the -- challenge that people face, is getting data into the backtesting framework. It used to take an hour and a half. Matt rebuilt the entire thing using polars. So now it takes about a minute, and
Yeah,
it's all hidden.
yeah, this was one of the biggest complaints of students is like having to download their CSVs or whatever and then figure out how to get those into, zipline format and this and that. 1 line of code.
Yep.
It used to be, I think, probably like 150 to 200 lines of code, and it was not like easy to understand, and it just totally simplifies everything.
Yeah, it just broke a lot. And this is the #1 most important thing that you need to do is get your backtesting engine working. And now it's one single function that's built into the automated process. So this is the third step. First step is price data. Second step is fundamental data. Third step is bundling all that data in a way that the Zipline backtesting framework can use. The fourth step then is to actually run the backtest. And for this, you can see that we create another simple function, and you're running. This is a little bit. We're actually using QS research for this, so we're gonna talk more about this when we use QS research. But just know here that 1 line of code is actually running the backtest, and why this is beautiful is because you're just passing in a single configuration which describes the backtest. And the configuration is actually um, a dictionary. Okay. So we will see this in a minute when we look at QS research. So in 2 lines of code, you run your backtest and you return the performance output, which we track. Okay. We will see this in a minute. So that's the 4th step, the zipline backtesting framework. So when we look at actually executing the trades, this is the, let's see, price data, fundamental data, zipline bundle, backtesting. Fifth step is to actually execute the trade. So this is the automated execution running our Omega execution engine. I like to call this the algorithmic trading SDK, right? So this gives you all of the code you need to run your algorithmic trading systems. And I'll show you what that looks like in a simple. But this is a strategy that I call rebalance. So this is a simple rebalancing strategy. Not a trading strategy, but a portfolio construction strategy. And if you don't know what that means, it's okay, but it's a pretty important thing we talk a lot about. So we create our instance to our trading strategy. So this is everything that you need is in this app object. Okay. This is this basic Python here. We're going to go out and get all of the positions that exist in our account right now. We then look at all of the positions that our backtest says we should have based on the last backtest run. We then go through a loop. So this is basically Python, pure Python. Go through every symbol that we want to divest, create a contract, which is how Omega treats how the object that Omega needs to trade, and then order target percent. So basically set the target allocation in my account to 0. So if none of this, if these words and this jargon means nothing to you, this is exactly what the program covers. This is just the code that makes this super simple. And I can tell you from having done this for 23 plus years now, being able to do this in 3 or 4 lines of code is a superpower. Just being able to set order target percent and setting your allocation of a particular stock to 0 is going out to get your market, like the actual value of your account, figuring out the current price of a stock, figuring out how many shares you need to buy or sell to set the allocation to that percentage point. It's doing all of that logic under the hood in 1 line of code. Then we actually get the trades that we need to place from our backtesting engine, loop through each one, and we trade it. Simple as that. We can trade, Matt mentioned, up to 32 different strategies at the same time. So Omega, and I don't know any psychopath that has ever done that. I've done 3 at the same time, and that was a lot. But you can set order references, and what that does is it tracks the strategy that you're trading against. And I'll show you what this looks like in a minute. Okay. So 5th step, this is how the actual executions work. And it's not that much code, 30 lines of code to do all that stuff. And then the last task is what puts it all together. Okay. So what I'm running now is this block of code. So I get a start date and an end date. I get my backtest configuration. I get my backtesting function. I'll show you what this looks like in QS research. I get the bundle name. This is for the backtesting engine. I get my strategy reference. So I haven't even shown you ML flow yet, but I will in a minute. I set my client ID. This is how I connect to my brokerage. And then I run the strategy. And this is the only, I don't know, what is this, 20 lines of code or so to run everything that I just showed you. And that's all being tracked here in our prefix server. Okay. So then this is our, so you can see the status of the tasks, right? So the price run took 2 minutes, 46 seconds. It didn't take long because I already ran this. And then my fundamentals is actually still running. This takes a while because there's, I think, 5 gigabytes of data. We'll look at this. There's tens of millions of rows of data here. So you can see this like really nice task management. So you know what's happening. And eventually when all this runs, you're going to see 5 or 6 different setups. And all of this is orchestrated. I mean, my hands are off the keyboard, right? I just ran Python qsmomentum.py, and all of this stuff runs on an automated basis.
Yeah, and I think one of the important things too that Jason's showing you is like the kind of the like the underneath the hood, everything that's running. uh, with our hedge fund. But like the fact is that you know, once you learn how to do it, it's only actually a few lines of code because you don't like all the stuff that Jason's shown you is already written for you.
It's already
It's
written.
yeah, it's already written. So and then you just run it and you'll know you'll see the config and all that stuff. So it's very cool, very powerful.
Yes. And Matt introduced me to Prefect. We were using another orchestration tool called Luigi to start, but we decided, well, Matt, you didn't convince me. You just said like you should check out Prefect. It's great. And I checked
Right.
out Prefect and it is
Well,
great. Just a
yeah, and
lot
I
easier.
actually I forgot about Prefect because Jason, you actually had it all set up using Luigi, and
Yeah.
then I'm like, well, and then one of our students brought up Prefect, and then I was like, okay, yeah, we should take a look at Prefect because it's got a few other bells and whistles that'll actually help us kind of scale things up. It's very cloud native. It's all that stuff. So
Yeah, and it's easy. It's like, I mean, the leverage that you get, I mean, for example, running this, you just decorate these functions with this task decorator, and it just shows up. It just knows that it's a task, right? So it's very, very easy to use relative to some of the other orchestration tools I've seen. I saw a comment about privacy. So the cool thing about this setup is it's all running locally, right? You're reaching out to get historical data, but you're not telling them anything about what you're doing. Everything here is running locally. It's not being sent anywhere. Prefect runs locally. I mean, I can show you right here. In this, um, it's running in this task here. So I'm seeing some errors. I don't know why, but um, this is the prefix server, and then this is the ML flow server. It's running locally. So let me show you guys ML flow. Just a one in the chat if you guys have heard of ML flow before. Have you guys heard of ML flow? If not, you're in for a bit of a treat here. Okay. So Philippe, this is a 2012 MacBook Pro M2 chip, basic $1,200 laptop. It does not take, it's 16 gigabytes of RAM. It does not take a ton of compute for this stuff to run. So what is ML Flow? ML Flow is part of our QS research package. And I'm going to just quickly introduce ML Flow to you, talk about what it does, and then I will show you how we use it. Um, Basically, ML Flow is a machine learning experimentation tool. And one of the big problems that we had found through this 18, I think 20 months now, Matt, journey is that I was a big Jupyter Notebook guy. And Matt was a Jupyter Notebook guy as well, but he quickly realized that in a data science and machine learning workflow, you can't really rely on Jupyter Notebooks for anything in production. It's all just experimental. And as we were making the move from
100%.
experimental research into actual production where our money will be at risk, we needed something more robust. So what ML Flow, or the way we use ML Flow, is that we track different iterations of our strategy back tests. Okay. And this is a great tool to do that. So just a quick example. I just ran this a month ago. Matt's running this, I think, every day, and maybe towards the end, Matt can show some more about ML Flow. But just to get you orientated, for every single back test run, it gives us a couple things. Number one, it tracks all of the input parameters. So this is one of the major reasons that we parameterized the back test. So we have a ML, I'm looking at the comments. I keep getting distracted. I got to stop doing that. We have
I'm handling the comments,
I
Jason.
know you
So
are. I know you are, but I can't help it. I see things moving and my eyes just track. We have a configuration-based back test. So everything is in a dictionary, and I'll show you this. And all of that stuff shows up as the input parameters. So you know exactly what is going into your strategy. And on the right side, you have 72 performance metrics. So not only do you know what's going in, but you know what's coming out. So as far as all the performance metrics you get, I mean, it kind of goes on forever. I always just look at the Sharpe ratio because this is the easiest one for people to understand. If you don't know what Sharpe ratio is, it's basically like a risk-adjusted performance metric. Okay, so I earned 20% returns last year. I had 20% volatility last year. My Sharpe ratio is 1. It's return divided by volatility. So I get 4 different ways of tracking the Sharpe, so the benchmark. So what did the benchmark do? So, and I think we use the S&P for this strategy run. Actually, I can probably find it in here, but I'm not gonna spend time doing that. But it would show up in here which benchmark we used. And our portfolio daily Sharpe was 2.5. So our portfolio beat the benchmark,
Yeah,
essentially is what I'm
if
saying.
you in that search parameters,
Yeah.
it just type in bench. Yeah.
Oh, it doesn't show up. Maybe it's
Uh,
hidden somewhere. It's
yeah, it
probably the
might be.
default. So I think we default to SPY.
Okay.
No problem. I'll show you where that shows up in a minute. So the other cool thing here, and I keep saying cool, it's not cool, it's like critical. Actually, this stuff is so important. Um, is that we have these artifacts. So after the back test is run and we execute our trades, we get all of the stuff that comes out of the backtest run as artifacts. So here you've got the configuration, which is a serialized path. So you can see it's running locally, file JSON, users JSON, work, quant science, etc. You can see that this is the configuration pickle that we serialize. This is the performance pickle. Pickle is just a serialized data frame. And then we've got this portfolio stats thing. It's a CSV that we embed as an artifact. A more recent update was the performance metrics. So we use a couple tools. One is called Alpha Lens for factor analysis. The other one is called Pifolio, but we actually convert the output into HTML files, and then we save those artifacts as well to show the performance of the strategies. So this is the back-tested performance between January 2024 and March or April, I think we're at 2025. You can see very, very nice equity curve on this momentum. This is our QS momentum strategy. This is Matt's bread and butter. But you get all of this stuff all automatic. So my hands are not on the keyboard, right? Like this is all automatically generated through QS Automate, which is our orchestration tool. Okay. So very easy, just a couple lines of code kind of runs all this stuff for you. Okay. So let's look at some of the libraries. The first one probably we should look at is QS Connect. We talk about this one a lot.
Yeah, we did get a couple of questions too on like the diagram or the architecture. So you might want to just take a second on that QS research or QS Connect. If you go back
Yes.
there, maybe explain, just kind of like walk them through that one, two, three, that visualization there real quick.
Yeah, absolutely. This is essentially the architecture that we've got set up. And we start with the QS Connect library, which is actually this repo here, going out to get historical financial data as well as historical price data. We pull all this into I mean, I'm literally, can you see this, Matt? You can see my Explorer here.
Yes. Yeah. Yeah. Yeah.
Okay.
Yep.
So
Wow.
you
All
see
the
that
Parquet
date
files.
modified today, right? So these are all the Parquet files. My data acquisition pipeline is still running. Okay. So what you're seeing here is all of these Parquet files. So bulk income statement 2023 annual, bulk income statement 2022 annual coming in, right? So all of these files are coming in being cached as Parquet files, and then it gets converted into a DuckDB database. So the one I ran in June was 4.5 gigabytes, excuse me. And the one that's currently being built is just under a gigabyte. This will weigh in at over 5 gigabytes as well. So that's what this first box does. It creates your high performance data lake. So this is Parquet, DuckDB, and Polar. So the fastest kind of data processing engines we have in Python. From there, we go to QS Research, and this is our machine learning based research environment. And I'm going to give you guys a third secret. This one's free. Professionals are not dumping price data into machine learning algorithms and expecting any sort of results out. That is not how the funds are using machine learning. So if you think you can have your deep neural network and you plug in prices into your deep neural network, and then somehow you get some predictive power out, you will not. You will lose money immediately. We are doing machine learning the right way, which is based on factors. Okay.
Yeah, we've done it the
Factors,
wrong way before too, and we know,
yes.
kind of what can happen if you overfit.
Everybody will do it, right? Because it's so easy now to import PyTorch or import scikit-learn or import whatever tool, run a bunch of prices through some model and think you're getting something that works. It
Right.
just doesn't, full stop. So the way we've created QS research is that we are doing machine learning on factors, and factors are um, latent drivers of returns. Okay. That is essentially what we're trying to do here. And what we were trying to do is predict returns, which is nuanced, but it's a big difference than trying to predict prices. And we're trying to predict those returns based on our input factor. So if you're a data scientist, you've heard of feature engineering. In finance, we call this factor engineering. It's the exact same thing. But to get the infrastructure right is very difficult to avoid overfitting, to avoid data snooping. And we've solved that through 18 months of work in QS research, which I'll show you in a minute. And then finally, we have Omega. So Omega is a algorithmic trading SDK. This is the Python tool that you use to actually execute and manage your strategy. So actually execute trades into your strategy and manage your portfolio, manage your risk. And I'll show you all this in just a minute here. Okay. All right. So the first library is QS Connect. And we've got, Matt's done a great job here giving lots of examples. You see how simple it is to use. You just create your keys, you create a client, get historical price data, historical income statement data, historical balance sheet data, cash flow data, financial ratio data, et cetera. Very, very, very easy to use. Um, I'll show you a little bit more. Oh, we've also got, sorry, going back, we've also got quite a bit of examples. So Matt and I have spent a ton of time on documentation. Um, you could just literally run this line by line, and this will all work for you, showing you how to interact with the DuckDB database. So you can actually connect to the DuckDB database and use polars, or you can write SQL against the DuckDB database. This is how you can create your backtesting bundle. So all examples work out of the box. Very easy to use. So if I look at the actual source code here, you go to client. This, if I go, where's my little, here we go. So here's all the methods that you kind of get in the QS Connect library, right? So bulk historical prices, this is one off, historical prices from Yahoo, if you don't have the FMP key, intraday prices, historical splits, historical dividends, a bunch of helper methods to cache data. So bulk income statement data, balance sheet data, cash flow data, ratios data, key metrics, growth rates in all of these different financial statements, all the financial statements, company profiles, stock lists, stock index constituents, stock screeners. Then we've got all the data manipulation, so managing the cache, making sure we're not duplicating data, loading the cache, looking at the data, manipulating the data. All of these methods are kind of these public methods that you get with QS Connect. So, I mean, I like to say I started QS Connect and Matt like took it to the limit. I think I wrote like 300 lines of code and Matt has 3,732 lines.
I think we all kind of like do our strengths too, like between me and Jason, because
Yeah,
no, not to say that this is not a strength of Jason's, but I've
yeah,
I've been dealing with, managing large data sets like this, tabular
forever.
data for like, 15 years now, as a data scientist. So like this is like, you know, kind of second nature to me to like he came up with the idea for the client. And then I just kind of integrated my like data processing stuff and
Yes.
yeah, now we got a data lake. So pretty cool.
It's amazing.
You want to show them like what the data lake actually looks like? Did you show them that yet?
Good question. Or good point. I did not. Okay, so I will get to Omega in a second. So on the left side, you see my like database browser. I forgot to show you guys this earlier. I meant to.
There's two databases there. That's why you see Omega and QS Connect.
Yes. So Omega is our trading database. I'll show you that in a second here. QS Connect is the high performance data lake. So if I go in here, you see the tables, and we're not running all of the data, right? So if you run back here, For FMP, I'm only running income statement, balance sheet, cash flow, and ratios. There's key metrics, there's the growth, there's a bunch of additional tables. For our purposes, we're only using these four. But you can kind of see in here the row count, right? So for the annual statements, we've got about 750,000 records in each of the annual financial statement data. In the quarterly financial statement, it's about 2 or 3 million records. And then the historical prices, there's 15 million records. And then the stock list, there's 86,000 rows. So 86,000 rows means that there's 86,000 stocks covered over the historical period. So if I look at what this looks like, I'm just going to look at the bulk ratios, the quarterly bulk ratios data. So about 3 million rows. And on the right side here, let me lower that a little bit. You can see the columns, right? So this is the data, all normalized, all standardized, all clean. You can see everything that we get: current ratio, quick ratio, cash ratio, days of sales outstanding, operating cycle, gross profit margin, effective tax rate, return on assets, return on equity, EBIT, EBT, debt equity ratio, on and on and on. You guys are seeing all the columns here. This is all the columns of data. So not only is it a lot of rows, but you've got, I don't know, 30 or 40 different columns here. So if you're a fundamental or quantamental trader or investor, you've got all of this data normalized, standardized at your fingertips. And this is where machine learning comes in. So I'll show you QS research in a second, but we are using XGBoost to find which combination of balance sheet income statement data give us the best opportunity for profit in our strategy. That's what the QS momentum is doing.
Yeah,
Okay.
yeah, I think that the key here too, so like you can see how much data, how many rows, the price data, for example, 15 million rows of price data. Like this is why like the CSVs get all kind of scattered on my computer because, when you're managing that amount of data for like all these different like statements and prices, it just gets messy. So this cleans it
Yep.
all up. Um,
Yes,
we we
absolutely.
we
And
are
it's high
getting a question
performance
on
too.
the config, like how do we specify a back test or how do we specify a strategy?
Yep.
So I don't know if you want to show them that, and then also obviously the Omega database. I think that'd be a pretty that's pretty cool.
Yeah, let's look at Omega quickly, and then what you're talking about, the config mat, that's QS research. So we'll
Yep.
look at that in a second. All right, so QS research, or excuse me, Omega, Matt calls it a hedge fund in a box. I call it algorithmic trading SDK. It basically solves a big problem for people, which is that last mile. The last mile is, we're all analytical people, we're all data scientists. We pull in our data, we do our Jupyter notebooks, or we do our scripts. We've got all this analysis. But then how do we take that analysis into action? How do we actually take our models, our strategies, our portfolios, and put them into the market? Right? How do we do that? If you're not a trader, that's very difficult. And data scientists people and analytical people like to do all the analysis. They like to look at the charts and the visualizations and the SHAP analysis and all this kind of stuff. But when it comes to get to trading, it's hard, right? It's very hard. It's an emotional thing. You're putting your money at risk. So Omega seeks to resolve that problem. And Omega is an event-driven modern Python app used for algorithmic trading. It takes full advantage of the Interactive Brokers IPA. IPA. I got beers on my mind. The the API. I got vacation coming up. I'm thinking about beer. The API. Okay. So what does that mean? So first of all, very, very heavily documented, lots of examples. So each one of these gray boxes is copy and paste, and it works. So you can get all the account information. So 250 or so pieces of account information, one line of code, single account value. This works with multiple accounts. So in Interactive Brokers, you can have many accounts. Portfolios, you can automatically syncs with your portfolios. So if you're trading, Omega will know. It will automatically update in the background when something happens. So you never have to worry that your stuff is out of date. Yeah, we'll talk about, Jim is asking 1 minute live SPX. Yes, we have 1 second bar historical data. We have live streaming L1 and L2 data. So book data and top of book data. Positions, all of this stuff is automatically updated asynchronously, P&L, trades, orders, fills, executions. Okay, so all of that stuff is automatically updated in the background. So here's market data. Here, real-time streaming data. So this is top of book data. We also have market depth for people that know what that stuff means. If you don't, it doesn't matter. Historical bar data up to 1 second bar data. So intraday 1 second historical data, all in just a few lines of code. So this block of code will give you 1 year of daily data. You can also get multiple symbols and you will return yourself a pandas data frame. Let me just scroll up here quickly and get to another section in Omega. Get to the bottom here, all features. So we've got an event-based system. So you can hook into all these events, meaning that if there's a new bar, trade, etc. I'm actually looking for the order types, Matt. Sorry, I went too far.
Okay.
Okay. So executing orders. So if you are a trader, all of this will mean a lot to you. If you are not a trader, then don't worry about it. We support market orders, limit orders, stop limit orders, market on close, market if touched, bracket orders. We have condition-based orders. So if price is greater than X trade, if volume, if margin is greater than X trade, execution conditions, percent change conditions. We have access to the full suite of algorithmic trading algorithmic orders that are available in Interactive Broker, so Iceberg, Dark Ice, etc. Trailing stops, hedges, scales, combos, randomized.